Okay, so now that our player has the ability to shoot lasers whenever they want to, let's give them something more interesting to shoot their lasers at than this asteroid, which they can't do any damage to. So we're going to go ahead and add an enemy into the game. Before we do that, I'm going to delete this asteroid from the scene because we've made it a prefab. We don't need to use it anymore at the moment. So we're going to go into our art folder and expand our sprite sheet. And I'm going to grab this first kind of alien, kind of brown looking ship here. I'm going to pop it down there. Now, to be able to interact with anything in the world, of course, we need to give it a box collider. So we'll give it a box collider 2D. I'm going to shrink this box collider down on the x-axis like that. But I'm not going to shrink it on the y-axis at all because we want to make it so that our player can actually shoot this thing and have a little bit of leeway that even if the player slightly would miss it, it's okay to hit the ship. So I'm going to leave it kind of touching just at the edges, and then we have this kind of area here where the player could hit it and kind of get a little bit of a lucky shot in, maybe, if they wanted to. Okay, so we've got our little ship in place here. That's all perfectly fine, but we obviously needed to move around within the world as well. So to move it, we're going to need to give it a rigid body. And we're also going to give it the basic movement script that we added to our asteroid. So we'll give it basic move, and we'll give it a move speed of, say, -2, so it'll move to the left. And it won't have any rotation because we don't want our enemy spaceships spinning around or anything like that. So that's grand. So let's go ahead and see how that looks in the game then. If we press play. Oh, we didn't turn off the gravity on the ship. Like that. There we go. And now our enemy ship slowly comes towards the player. Of course, we're not destroying them at the moment. That's fine. But it's kind of a bit bland as well. We don't want our enemy ships just moving towards the player. So let's make our basic movement script a little more interesting so that they can also move down the screen or up the screen depending on which way they want to go. So let's go into our basic move script. Now we could go into our scenes folder and everything like that if we want to, or we can just click right here where we have the script being kind of shown but grayed out. If we just double click on that, it'll open up all the same in mono develop. Of course I still have it open here anyway, but that's okay. So then what we want to do is, here where we have our move speed being applied to our rigid body velocity, instead what we're going to do, instead of having just move speed, we're going to have a move speed X for when we're moving on the X-axis, and we'll apply that down there too. And then we're also going to have a public float move speed Y. And we'll use that for moving on the Y-axis of our rigid body velocity. So we'll just say move speed Y there. So now we can set it so that this ship will have the ability to move up or it can move down depending on where you place it. So let's, for example, once this is compiled, and we can go back to moving, there we go. Let's put this ship up here on the screen, and we'll set its X speeds to be, we'll set this one to move a bit faster, so it'll go at -3, and we'll set its Y speed to be -2. So as it goes across the screen, it'll also slowly move down the screen. So let's hit play, and now you'll see it's a bit more of a threat with this ship moving down the screen as it goes. So it's a little bit more interesting, a little bit more of a kind of nice look going on. So now that we have this enemy moving around, let's see if we can make it be destroyed by our bullets. So we want to make it so that our enemies get destroyed whenever our player shoots them with the bullets. And a simple way we can do this is just when our bullet hits against the enemy, we can just do a check and see if it has the correct tag. And if it has the correct tag, we'll just destroy whatever the other object is. So the tag we'll use for our enemies themselves, and we'll actually just rename this one because at the moment it's got a big long name. We'll just say enemy 1, nice and simple. So if we scroll up in our inspector, we're going to go to our tags, and we're going to add a new tag, and the new tag we're going to use will be enemy. So we'll pop back to our enemy guy and give him that tag now. So he has that tag, so we know we're fine with that. So now if we go to our bullet controller script, we can set it so that if it encounters anything with the enemy tag, destroy it. So let's go into our bullet controller script here. There we go. And down here where we're on trigger entering and checking what things we run into, just below where we destroy our game object, it doesn't really matter if this comes before or after our destroy game object, but we can just add it in here and say if the other dot tag equals enemy, then what we want to do is destroy other dot game object. So let's save that. If we go back into the game now, that should be all we need to do. That simple little bit of code will allow us to destroy any enemies that we encounter along the way. So we can press play here. We'll let him come towards us. And boom, as soon as our laser hit him, he gets destroyed. So perfect, that works perfectly fine. But let's just take a look about what happens if we don't let our enemy get destroyed. We just let him go down here, travel off the screen, and if I just pause the game here, we can see that our enemy's gone off the screen, but now he's still alive in our hierarchy and he's still moving off, and he'll be moving forever and ever. So much like we did with our bullets, as soon as they left the screen we destroyed them. We should probably do the same thing with our enemies that are moving down here. So we're going to go ahead and go into our basic movement script and say, okay, if this object has left the screen, so we're going to again call our void on became invisible, and we're again just going to say, okay, we've left the screen, so we don't need to be in use anymore, so just destroy this game object. Perfect. So we'll go back in and just make sure that that's working, and once it's done we can play our game. Now we can see our enemy goes down, we have our enemy 1 here, and boom, it's gone. Perfect. So that's all fine and dandy. Let's go ahead and take a look at what we want to do next, which is, so it's fine, our enemy can move down the screen, but he's completely defenseless when our player arrives in here. So let's give our enemies the ability to fire back at our player. So now that our enemies are able to be destroyed when we want them to, we want them to cause more of a threat to our player, so let's make our enemies be able to fire a laser back at us. Now to do that, what we're going to do is use the same bullet controller that we used for our player's laser, but we're going to use a different laser type for the enemies to be able to distinguish between them basically. So we're going to go into our art file, and I'm going to click and drag this kind of tin red looking little laser. I'm just going to pop it here just for easiness sake, so we know we're dealing with the enemy laser. We're going to add a box collider to it, as we did with our previous one, and we're going to give it a trigger so that we know it has a trigger. Then we're going to add the bullet controller script to the laser as well, like that, and we're going to set the move speed to be minus 15 instead of 15, so this way it'll be moving off to the left. Then we can set our bullet impact, but rather than just using the same bullet impact that we use for our player, let's make it a bit different, and we're going to go to our prefabs folder. We're going to drop our laser impact back into the world, and we're going to change the color of it to be red. But before we do that, we're going to change it to be no longer a prefab that we've created, and to do that we'll make sure we have it highlighted here, and then go to game object and then break prefab instance. So we're going to change the name of this now to be enemy laser impact, and now over here we'll change the start color to be red. I'm going to turn back on looping so that we can just keep watching it in action, and hit the simulate button here. And we're going to change the other start color to be kind of close to yellow really. So there we go, that'll be the impact from when this laser hits. So that's absolutely perfect, that's what we want. We'll turn looping back off again, and now we'll make this a prefab as well. We'll delete it from the scene, and now our enemy laser, we'll rename this to be enemy laser, give that the enemy laser impact like that, and we'll click and drag that in to be prefab, and that's absolutely perfect. So that's all fine and dandy. So the next thing to do is make it so that our enemies are able to fire, and we'll make use of the same kind of idea that we use for making our players be able to constantly fire when we hold the button down. But we're just going to assume basically that our enemies are constantly holding the button down to fire, so we're going to make them repeatedly fire. But rather than adding this to our basic movement script that we have back here, what we're going to do is create a new script to handle our enemies shooting, because we might add some different ways that we want our enemies to move, but the ability for them to be able to constantly firing that's a very basic skill that we want our enemies to all be able to have. So we're going to separate that out into its own script. So we're going to create a new C# script that we'll call enemy shoot. And we'll open this up. Let us give it a second to load. There we go. We got our enemy shoot here. And what we're going to do is, obviously we need a reference to the bullet that we're firing. So we'll have a public game object that we'll call the bullet. We'll need the place that it's going to fire from. So that'll be a public transform bullet point, much like we had for our player. That should probably have 1 or 2 L's, not 3. Much as we had for the player, we're going to need a way to count down our shots. So we'll have a public float shot delay for how long we last between shots, and then a private float shot counter for counting down between. And then down here in our update loop, we're going to say if our shot counter is less than equal to 0, so if it's less than 0 or if it is equal to 0, then we're going to make ourselves instantiate a bullet. So we'll instantiate a bullet in the world, and we'll instantiate at our bullet point position. So bullet point dot position, no, dot bullet point dot position. There we go. I was typing in the wrong thing. And then we'll set the rotation of it to be bullet point dot rotation. Perfect. So there we have our laser being instantiated. So if our shot counter is gone below 0, we'll need to reset our shot counter back up to full. So shot counter equals shot delay. And then after this, oh no, actually we'll put it before all this little bit here. We'll just say shot counter minus equals time dot delta time. So it's constantly ticking down the whole time, and then when it gets below 0, it fires the bullet and starts counting down again. So perfect, that's all we need to do to create our little enemy shooting script. Let's go back into our game and hook all that up. And of course on our enemy himself, we're going to need to set a fire point that our enemy shoots out of. So we'll give this a second to compile. There we go. And then on our enemy, we're going to give him the enemy shoot script like that. We're going to have a longer delay on our enemies between shots, so we're going to set that to be 1 second. Let's give our enemy over here the point that he's going to fire from. So we're going to right click on him and go to create empty, which will create an empty child, and we'll just call this our shot point. And we're going to move this so it's in front of our enemies like that. Then back over here on our enemy, we're going to drag that shot point into the slot there, and then we're going to drag our laser prefab. So our enemy laser impact prefab. Oh no, sorry, we are dragging the enemy laser into here, aren't we? Just the enemy laser into our bullet slot. I was overthinking things there for a second. So now we should have our enemy set up so that every second he'll fire a laser out. So we can hit play here. So that's all fine. He's firing his laser, but at the moment, when they hit the player, nothing happens. So let's set it up so that when an enemy's laser hits the player, it destroys him, just like the asteroids did. So we could do this by, say, we could add the hurt player script to our lasers. So I've attached that to our enemy laser now. And if we press play, it flies along, and if we can line it up, oh, there we go. It hits the enemy and destroys them. So that's one way of doing it. We could also do it, if I just remove that from our enemy, we could go here and we could set it so that on our on our bullet controller script, so here we have the other tag is the enemy, and it destroys the enemy object. We could set another tag here to say if other.tag equals player, for example, like this. Then we will destroy the other object as well, so we'll destroy the player. The only problem with doing this is it creates a bit of an issue for us, where if for some strange reason our player shoots one of his own lasers and accidentally runs into it somehow, which is something that can occasionally occur. It could be a freak kind of weird thing that happens. But basically, we don't want our player accidentally shooting a laser and it destroys itself. So if we want to use this way of doing it, of having it hard-coded into our bullet controller object, we need to add an extra variable into this script. So we'll go up here and we're going to add a public bool that will be called hurt player. So basically we'll add this in to say if other.tag equals player and hurt player is true, then we will destroy the player. But if hurt player isn't true, then we can just assume, okay, we're not being we're not the player laser, basically. So if player laser, or if hurt player isn't true, then that means that we're firing it from the player itself, and it should be able to, we don't have to worry about it actually hurting the player. So we can just save that and go back in here, wait for that to compile. And now over on our enemy laser, we need to just mark that little text box that says hurt player and make sure that on our player laser, that box stays empty. So now we don't have to worry about our player accidentally running into his own laser or anything like that. So those are two different ways to do the exact same thing. Either way works perfectly fine, whichever way you want to use in your own game. I'm going to stick with this way that we just added into the game here. It's a little bit more complicated, but we have a bit more control over things in that situation too. One extra little thing that we can do to make things look a little bit more interesting is if we're firing at our enemy here and he gets destroyed, all that's left is the impact effect of the bullet, which kind of looks a little bit interesting, but it would be more interesting if we had a special effect for when our enemies are being destroyed. And we can do that using the skills we've already learned of instantiating a new particle effect object, which will represent an explosion. So all that would maybe have a few more particle bits going on, and that will be showing how our enemies are exploding. So rather than me stepping through that, it's topics that we've already covered. I'm going to jump ahead and show you an example of that working in the game, and this is a challenge to you to go ahead and repeat it yourself and demonstrate that you're able to do these things in your own game. So just as a demonstration of how this can look in action, I'm going to hit the game here. I've already set this up, and if I shoot our enemy, boom, we get a nice little explosion effect. Now, the project files will be available at the end if you want to see how it's done. And if you want a small hint, I will give a hint in a couple of seconds. So if you don't want the hint, go ahead and do it yourself. But if you would like a small hint of how I've done it myself, basically all we're doing is saying that when our player laser destroys our enemy, we want to instantiate a new effect. So I've created a new particle effect here, which just has a simple bit of an explosion kind of look to it, and it also has as a child another explosion that has these kind of slightly larger black and grey effects. That's all I've done. Very simple and very straightforward. You're free to go ahead and try and do it yourself the exact same way. So we've got our enemy able to move around nicely. We can make him move in a straight line, we can make him move diagonally, or we can make him move diagonally up and move basically in those kind of rigid straight line directions. But let's give him a little bit more variety and give him the ability to kind of change direction when he's after reaching a certain point on the screen. So we're going to create a new movement script for our enemy here. And before we do that, I'm actually going to remove the current script that he has attached to him. So I'm going to remove this basic movement script by clicking on the little gear in the top right and then selecting remove component. And then we're going to go into our scripts folder and we're going to create a new C# script that we're going to call, we'll just call it enemy movement. So it's a slightly more advanced enemy movement, not just basic anymore. But it's still not going to be too complicated for us to move around in. Once it's loaded up here, first thing we're going to want to do is we want to make sure that we still make it so that our enemies are destroyed when they leave the screen. So we're going to keep the same void on became invisible that we had before, and we're going to say as soon as our enemies become invisible, we want them to be destroyed, not destroy over time, we want to just destroy them. So destroy game object, like that. So perfect, that's what we want that to do. And the next thing we want to do is talk about how our enemies are going to move. Well, first of all, we'll give them a certain move speed, because no matter what, they have a value that they're going to use to move to the side. So we're going to say public float move speed. But again, we're going to have a move speed X, and we're going to have a public float for move speed Y. Now, we're not just going to have it so that our enemies can move to the left and also move down at the same time. What we're going to do is have it so that our enemies move to the left to a certain point, then they can either move up the screen or move down the screen, and they'll start moving in that direction. So say we'll wait till they get 5 units into the screen, and then we'll tell them, okay, at this point, move down, and then they'll start moving downwards as well as to the left. So to do that, we're going to take advantage of using switch cases, which are something we haven't encountered yet at all, but are very simple and very easy to use. But of course, if we're going to be moving our objects around the world, we want them to have their rigid body that makes them move around. As previously we used in our basic move script, we used our velocity to move. We're still going to use that on our enemy movement here. So we're going to have a private rigid body 2D that we'll call the RB, and in our start function we'll make sure and we'll get that functionality, or we'll get that rigid body, we'll get the rigid body equals get component rigid body 2D. So perfect, we got our rigid body set up there. One other thing we're going to need to know is how far in are we going to move before we are deciding whether to move up and down. So we'll use a value to establish that. We'll say public float Y target. So this will be a Y position on the screen. No, actually this should be X target, sorry, not Y target. This will be an X position on the screen. So if we just pop back into the game here, say we'll set it to be at this position here, which would be at the value 3, which will be, we have 0 at the center, and then 1, 2, 3 is here. So say once the ships travel into this point, then they'll start moving down the screen there. So we want to use a variable that will decide which movement type our enemies are going to use. We could want them to move up once they reach a certain point and just keep going up, or we could want them to move down once they reach a certain point and just keep going down, or we might want them to go to a certain position on the screen. So say if they start at the top of the screen, we might want them to move towards the bottom of the screen, but then instead of just going completely off, they'll stay there and just stay at that level while they move off to the left of the screen. Or we could have them start at the bottom and move all the way up to a certain position near the top and keep traveling to the left that way. So to do that, we're going to have a certain amount of movement types, and to keep track of it, we'll just create a public int that we'll call move type, like this. And we're going to keep track of what we want our move types to be. So we'll say here, we're going to add a comment just after this. So we type // and that means anything else we type on this line won't appear to the computer. It won't recognize anything else we type here. So we're just going to say // and we're just going to write and say to ourselves, 0 will be for moving up at X target. 1 will be for moving down at X target, and then 2 will be for moving to a point. So we're going to have it move towards a certain position on the y-axis. We're not going to set that up just yet with any references here. We'll return to that in a little bit. So we'll set up these first two simpler cases first. So as I said, to handle this, we're going to use a thing called a switch case. And a switch case basically works on, it takes in a value, or a variable, which in our case is going to be this move type variable, and it checks and sees if it's equal to any particular cases. So for example, we're going to check and see if move type is equal to 0, and if move type is equal to 1, and if move type is equal to 2. So to do that, in our update loop here, we're going to say switch, and then in a bracket we're going to type move type, because we're using a switch and we're wanting to check it against the move type variable, which is what we're using here. And then below that, we're just going to type our curly brackets here like this. And then in the space in between, we're going to type here case 0. So what we're saying is if our public int move type is set to be 0, then we're going to use this movement type, so moving up at X target. So here we would type in a bunch of code to do our movement. And actually we'll go ahead and do that before we look at our other cases at all. So in our case 0 situation, we know we're going to start moving up once we reach the X target. So the first thing we need to do is see if our enemy object has reached the X target value yet. So we'll say if our transform dot position dot x, if that is less than what our X target is. And the reason we check if it's less than is because, remember, our objects are moving from the right of the screen and moving to the left, so the X position of it is getting lower and lower, and we want to check if it gets lower than whatever our X target is at this particular point in space, say, and then it keeps going. So if our transform position is lower than our X target, then we know at that point we should be starting to move downwards. So we can say, okay, in that case, then our rigid body dot velocity should be set to equal to a new vector 2 that on the x-axis we'll be moving at our move speed x. So we'll say move speed x, and on our y-axis we'll be moving at whatever our move speed y is. So we'll say move speed y. Now we'll just close that little bracket and put our semicolon. But before we move any further, so our move speed x and our move speed y, we're only really going to want to put a positive value into them in our inspector. And that's because our move speed y will change depending on whether we are moving up at X target or moving down at X target. So we want to make sure that no matter what, we're going to put in the same move speed y here. And basically, if we're going to move down, we'll change it so that our move speed y will here be minus. But if we're going to move up, we'll put it to be positive. And we might as well, to make sure that we maintain that and that there's no confusion within it, we want to make sure that our move speed x can just be put in as a positive value as well. So no matter what, we always want to have a minus velocity then. So we'll say minus move speed x and minus move speed y. So if our transform position is below our X target, then we'll start moving down. Otherwise, we want to set our rigid body velocity to be equal to a new vector 2 that is going at minus move speed x. So we're traveling along on the x-axis, but on the y-axis we don't want it to be moving at all. So we'll say 0 and we'll hit our semicolon. So let's just test this out before we go any further with our movement script. So we'll save that, we'll go back into our game. Compile. Oh, we've got a bit of an error. Of course we do, because there's one thing you have to write at the end of our switch statements. So at the end of every one of these individual cases, we want to type the line break. And what that means is it knows that this is the end of the switch, so we can get out of this and move on to doing other things if we have anything else in our update loop. Otherwise, it just moves on to the next update loop. So we'll just save this again, go back in here, let it compile, and once it's finished spinning in the corner, there we go. We'll go to our enemy, we'll give him the enemy movement script we just created. So our move speed x, we'll set that to be, say, we'll give him a movement speed of 5, or stick with 3 actually. We'll set the y movement speed to be 2. Our x target, for the point at which we'll start moving down, we'll set that to be 2, say. So at this point, kind of when he reaches nearly the middle of the screen, it'll start moving down. So we'll set our x target to be 2. And our move type we'll leave at 0 because we know that's the one we want where our enemy ship starts moving downwards. Okay, so let's test this out now by playing the game. So we see our ship starts going, and then at this point he starts moving down. So perfect. Now it's adding a little bit of variety into the game. Maybe we'll make him move a little bit faster because he's kind of not finished moving down by the time he gets to the edge of the screen here. So we'll just say move speed down. Let's move him at 4. So it's a bit more extreme and a bit more of a challenge to the player. So imagine if you had multiple enemies doing this. You had enemies moving down when they got to the player. Oh no, the player doesn't know what to do, so he kind of gets destroyed. So that's perfectly fine. So let's go ahead and do the same thing for moving upwards. So if we're moving upwards, then we know we want to have it on case 1. So if we set our move type to be 1, well, in that situation, basically we want to use the same bit of code that we used here. So we'll copy all of this if statement. But now instead of when our X position goes below X target, instead of our velocity changing to move downwards, we want to change it so our movement is going upwards. So nice and simple, that's all we need to do. But we need to make sure that at the end of this case, we type in break, like that. And we'll go, oh, we got a bit, oh, that should be a semicolon, not a colon. There we go. We'll pop back into the game. Let it play out here. And we'll hit play. Oh, we didn't change the movement type, I just realized. We'll actually just move him down the screen here so that we can see that. We'll go to our enemy. I've got a bit of an error up here and down here when you run the game, and that's related to how I set up the explosion effect in our previous video. I'm going to fix that up in a second, but we'll just sort this out first. So we got move type 1 to move him up. I'm going to press play, and we should see our enemy starts moving upwards as soon as he reaches that point in space. So I've got a bit of an error I'm just going to quickly fix. I set up an explosion for when our player shoots an enemy, but we've got an empty slot now on our enemy laser, so I'm just going to fill that in with an enemy explosion, even though our enemy lasers won't actually ever encounter that. But that's fine. So we've got our bit of movement in place. Down here then, we've got our third case, which will actually be oh no, this should be inside the curly bracket. I put down that a bit too far. So our third case, which will actually be case 2. So in this situation, what we're checking for is our player moves down to a certain point. So we'll still have it that we're checking to see if the player gets below a certain X target. So we're going to use that here. We're going to say if transform.position.x is less than our X target. Then we'll do a little bit of code here. But we also want to check if the player is at a certain position. So we're going to create a new variable here. Just below our X target, we're going to create a new public float Y target. And we're also going to add an extra step for allowing our players to be either moving towards this Y target up or Y target down. Now we could add an extra move type here, so we could have be a second move type, but we're actually going to do a fourth move type, which would be number 3. I don't know why second came into the case there, but what we're going to do instead, just to give us some variety and some extra options, we're going to add a public bool for move up. So what we're going to check down here now is say if move up. So if we're moving up, or if our ship should be moving up, well, in that situation, we're going to check again if our ship, if our transform.position.y, if it's greater than where our Y target is, so our Y target on the map. Well, if it's greater than our Y target, then we want to stop moving up. So we'll say our rigid body dot velocity should be equal to new vector 2 minus move speed x, and we don't want it to keep moving up anymore, so we'll say 0f. Otherwise, if our transform.position.y is not greater than our Y target, then we want to be having our rigid body velocity moving upwards. So instead of 0f, we'll have it going to move speed y, so it's pushing our ship upwards. So that's what's happening if our ship is moving up. But if our ship isn't moving up, well, that means it must be set to be moving down. So we'll do the exact opposite, but we'll copy that bit of code, we'll paste it in here, and we'll say, okay, check and see if our transform position is below our Y target, because if our ship is going to move down, then its Y target must be lower. So we'll say if it's below the Y target, then we don't need to go down anymore, but if it's not, then we want its velocity to be pushing us downwards. So we'll say that, save that. And we have one final else to add in here, and this else is checking if we haven't made it as far as our X target yet. Well, in that case, then we should only be making our rigid body velocity move us to the left. So we'll say vector 2, and we'll just copy the rest of this little bit of code here like that. And then finally, we've come to the end of our case, so we can break out of it. So there we go. We'll save this. We'll go back into the game. Like I said, we could have just made that be case 2 and also case 3, but we wanted to vary it a little bit and make it a little bit more interesting. So we'll wait for that to compile. Go to our enemy. Let's set our Y target for this guy to be, we'll say he'll move towards a Y position of 1 here, so he doesn't go all the way to the top of the screen. Actually no, we'll set it to be 2, so he's not quite in the middle. We want this one to move up, and we're going to set our move type to be move type 2. Oh, we had a bit of an issue there. Oh, what's happening is our our little guy here is running into its own laser, which obviously isn't very good, because when he's being instantiated, he's immediately firing his lasers at him. Oh, I just realized, no, he has a shot delay, so that's okay. Let's press play again. That was what was causing the error, because the lasers are destroying themselves. So that's going to be an issue that we're going to have to fix up. For the moment, what I'm going to do is I'm going to remove that enemy explosion that I had reset back into the game, and we're going to hit play, and we're going to fix up that little error in the next episode. So now we just can see our ship, it moves up to a certain point, and then he keeps flying off to the left, just the way we wanted him to. So now we've got some more interesting movements going on in the game, but we've got this bit of an error that's being caused by the fact that our enemy ships are somehow managing to be able to shoot themselves, which obviously that's not really what we want them to be doing. So let's take a look at how we can fix that in the game. So at the moment, we're getting an error where our enemies are being able to shoot themselves. Now, as an example of this in action, I'm just going to go to this enemy guy here. If I set it so that he can't move at all, he's just starting on the screen, of course he won't have the problem where he's shooting himself. If we just started playing here, he's just shooting away, that's grand. But if I was to, for example, create a duplicate of him, and go to our scene view and move him there, what's happening is he's being shot by his little friend here. So if we were to have multiple enemies on the screen in a line, they'd be able to shoot each other and keep destroying each other, which obviously that would be no good to us at all. That's not what we want to be happening in our world. So what we're going to do to fix that is set it so that all our enemies, as well as their lasers, are on the same layer. They're on a specific enemy layer, and we're going to set the physics system in Unity to make sure that anything that's on the enemy layer won't be able to interact with anything else on the enemy layer. So if I go to our enemy laser to start off with, we go to layers here. There's a few different layers in action, but they're not ones we want to use, so we're going to add a new layer that we're going to call, we'll just call it the enemy layer. We'll go back into the prefabs, that's where we were. Go to our enemy laser, and we're going to set that to the enemy layer. And then on our enemy ship in the game, we're going to set that to be on the enemy layer also. We'll change the children, that's fine, it doesn't really matter too much. One other thing we want to do while we're here, we might as well make our enemy ship be a prefab, because we're obviously going to want to reuse that in the future. And then the next thing we want to do is make sure that our enemies can't run into each other. So I'm going to make this enemy a copy of this enemy here. So if we play the game, we'll see now that they will shoot each other just like that. And one other thing that will happen is our enemies will also run into each other, which won't be very good. So if I just, as an example, take that first enemy and start giving him some movement speed, he'll go along and he'll run in, and whoa, that's not what we want going on either. So we don't want them to be able to interact with each other at all. So I'm going to, we'll leave that other guy there. But what we want to do is just go into Edit and go into our project settings and then go to Physics 2D. And then over here, you get this kind of cross-reference grid that shows which layers can interact with other layers. So at the moment, our enemies can interact with every other layer, and everything that you create within Unity starts off being given the default layer, except UI. UI is one of the things that will automatically be given the UI layer tag. But our enemies, now that we've given them that enemy layer, we want to make sure that where our enemy layer here interacts with our enemy layer here, we're just going to untick that. So what that means is, from this point on, anything that has the enemy layer attached to it won't be able to interact with anything else that has the enemy layer. But our player will still be able to interact with that layer, because default and enemy here on the list are having the little tick beside it, which means that they're able to interact. So just as an example, if we go back to our player, we can see our player is set on the default layer. So now let's press play, and we should see that the lasers now from this enemy will go through this one. Just perfect, there's nothing being destroyed there. And if we go back to this enemy and give him some movement, there we go. The enemy is perfectly able to pass through him, and there's no kind of problems being caused by that. And the reason we want to do that is because if, for example, I'm going to delete this original enemy, I'm going to restore this guy's movement, because generally speaking we want our enemies to be able to move a lot of the time. I'm going to apply that change. I'm going to pop another enemy into the world. Actually no, I'll just duplicate this one so that we get them in the same position. And this guy I'm going to move up to the very top. I'm going to set his Y target to be -2, and he's going to move down instead of moving up. And if we hit play, so say you might have a bunch of enemies on the screen, and they come in from the screen and then they cross over and fly across each other, and you don't want them to bump into each other in the middle of the screen. So that's why it makes sense to have your enemies be able to not interact with each other at all. So before we go any further, we want to take a look at adding more enemies into the game. And this is going to be an extra challenge for you. We've now got some different move types that we can give our ships. We've got them the ability to shoot. So I've gone ahead and added a couple of enemies into the game here. But what you should do now is go and create a variety of enemies yourselves that have different move types. They move to different positions on the screen. They attack in different ways. So say, for example, these guys all shoot. These guys up here only hurt the player when they run into them. But what you should do now is go and create a bunch of these yourself. I'll just show you these guys in action here as kind of a bit of inspiration. But we're going to make use of different enemy types as we go further into the game, and we want to be able to mix things up and make it a little bit more interesting for our players playing the game. So go ahead now and create some more enemies for us to destroy. So now at this point you should have a variety of enemies that you can use to send at the player. I've got a few down here that I'm going to use in the upcoming videos. But what we want to do now is create the system that will make waves of enemies keep coming throughout the game. And we're going to use a wave-based system, as I just said, which will contain a bunch of enemies appearing in a row that will attack the player. Our player will deal with them, and then the next group of enemies will be sent in. So to do that, we're just going to set up a couple of simple waves into our game here. So I'm going to create an empty object that we'll call, I'll just call this one Wave 1. I'm just going to push this over to the side here. Then I'm going to drop a couple of enemies into position. So say this guy here, this guy here, this guy here, and this guy a little bit more forward like this to make it a little bit interesting. So these two guys here are both going to be moving up, and these two guys here are both going to be moving down. I'm going to create another wave create an empty, oh, not as a child, I want to drag that out to be, we're going to call this wave 2. I'm going to move this over to the side here, and I'm going to drop a couple of these guys like this. This one here, this one here, this one here, and this one here. And again, I'd recommend you go ahead and create a few waves of your own. We're going to make these, obviously all these objects at the moment are just kind of being thrown into our hierarchy randomly, but we're going to set them out to be in a more sensible position. But for this guy, so these ones on the bottom here should be set to be moving upwards, and these ones here should be set to be moving downwards, so they're already set to that, I just realized. Their X target, I'm going to set that to be about 3, so they move into the position at the right place. So I have all these 4 guys highlighted here, so I'm going to make sure that they're part of wave 2, and then these other 4 enemies here, I'm going to make sure that they're part of wave 1. And then we're going to make both of these waves here a prefab. So rather than just popping them into this prefab folder, we're going to make them into their own special folder in here. So we're going to go create a folder. So this will be a subfolder in our prefabs. So we're going to have it be in waves, and then we're going to have another subfolder here for level 1. So these are going to be the enemy waves in our very first level. So I'm going to pop both of these in there like that, and then I'm going to delete them from our scene. Well, before I delete them, I'll just make sure that they're not doing anything crazy when we play the game. So if we go ahead and play here, you'll see, there we go, our enemies are kind of moving around. They look a bit weird, but that's because we've just very quickly thrown them together, but that doesn't matter too much. Obviously in your own game you'll want to have your waves be a little bit more sensible, but that's okay. All that matters for now is that we have these waves in the game. And to use them, we're going to create a new script which will control our waves and control, generally speaking, how our entire game is run, and that's going to be our game manager script. So now that we've got a bunch of waves created, we're going to want to create the system that will manage these waves. So we're going to go into our scripts folder, and we're going to need to create a game manager script. So we'll go to create C# script game manager, which will obviously manage how our game is running at any particular time. We're going to add this to an object in our hierarchy here. So we're going to create an empty object that we'll call game manager. It doesn't really matter where that is in the world, but what we also want to do as a child of this, we're going to create a point in space where our waves will start to appear at. So we're going to create a wave spawn point, and I'm going to move it so it's just off the screen over here, so that way when our waves are being brought into the game, they'll appear off screen and then start coming towards the player. So I'll put Ashley a little bit closer to the screen like that, so they'll start appearing and flying in and trying to do some damage to our player. So that's perfectly fine. The next thing we want to do then is go into our actual game manager script and start creating some code that we can use. So we'll go in here, wait for it to load, there we go. So we created that spawn point, so let's make sure that we remember to use that. So we'll say a public transform wave spawn point. So that's going to be the point in space where our waves get loaded into. Oh, that should be transform. And the next thing we want to do is know what waves we want to bring into the game. Now, if we want to bring in a whole bunch of waves, we don't really want to have to create a bunch of references to individual wave game objects. So we don't want to have, for example, public game object wave 1, public game object wave 2, etc, etc. We don't want to go through doing all that. So instead what we're going to use is a thing called an array. An array is basically a big long list of, in our case we'll use it for game objects, so it's basically a big long list of game objects that you can move through that array and say which game object you want to take from that list. So just as an example, I'm going to say public game object, and we're going to make it an array by putting 2 square brackets just after it, so that means it's a game object array, and we're going to call it waves like that, and then we're going to save and pop back into Unity. And when we're in here, we're going to go to our game manager and give it the game manager script, obviously. So where's that? Pop it there. So now we'll see Okay, we have the reference for our wave spawn point. We might as well fill that in while we're here. And then we have this little drop down here for waves. And at the moment, all it says is size 0. And that's because we haven't added anything into this array at all. So let's go into our waves prefab folder, into our level 1. I just created another another wave of random asteroids here. But let's go and grab wave 1 and drop that into our array. And we don't drop it in where it says size here. We drop it on top of where it says the word waves, because that's the name of our array, and that is whatever our array is. And if we drop it into place, we see we get element 0, and that's our first game object in the array. So let's go and add another one. So we drop that on top of waves. Now we have a second object and a third. So an important thing to remember about arrays in general is that the first object in the array is referred to as element 0, and it's due to the way how computers recognize stuff. Anything in first place will always be 0, and it counts up from there. So it starts at 0 rather than starting at 1. So our first position in the array is element 0, then the second place is element 1, third place is element 2. So it's just an important thing to keep in your head when you're referring to arrays, is that it's not starting at 1, it's starting at 0. So here we have the example of our game objects all lined up here. The next thing we want to do is have a number value which will count down how long we wait between each wave before we load the next one, and also how long we wait before we load the first wave. So to do that, we're going to go back into our script, and this time we're going to create a public float array that we'll call wave delays, and that'll be what we use to count down how much time we have left until the next wave. We also want to know if at this point in time we want to actually be loading waves into our game. So we're going to use a public bool for that. So we'll say public bool spawning waves. And the reason we'll do that is, say we might want our player to destroy all the waves, and then once it gets to that point where it's destroyed all the waves, we'll stop bringing in any more, and we might want our player to be able to fly on a little bit further, or maybe have a bit of a countdown to the end of the level or something like that. So that's why we want to make sure that once we get to the end of our waves, we stop spawning any more of them. And then finally, what we want to also have is a private int that we're going to call wave tracker. And I'm going to use this to keep track of what wave we're currently on. So say when we're on wave 0, what we'll do is count down our waves delay on our float array. So it'd probably be easier if we just can visually see this. So I'm just going to save that, and we'll pop back into our game manager here in Unity. Wait for it to compile, and once it does, there we go. So we've got our wave delays here. At the moment that's empty, but we want to make sure that this is the same length as how many wave objects we have. So I'm going to set this to be size 3 and say we're going to wait 5 seconds for the first array. We'll wait maybe 3 seconds for the second one, and we'll wait another 5 seconds for the third one to pop in. So back in here, the way the logic of this will work is we'll wait 5 seconds, then we'll load this first object in the array. And the way we'll know that which position in the array we should be at is using our wave tracker. So by default it'll start out at 0, so we'll start counting down element 0 here in our wave delay, and once that gets below 0, then we'll go okay, load our game object at position 0 as well, and then we'll make wave tracker move on to being 1. So then we'll go to here and we'll go okay, start counting down this wave delay, and if that gets below 0, then hey, move on to the next object in our array, and then start counting down again, and so on until we reach the very end of our array. So let's take a look at what code we can do to actually start doing that. So first of all, we need to know if we're allowed to spawn waves at the moment. So that's the first check we'll do. We'll say if spawning waves. So if spawning waves is true, then that means we're allowed to start cycling through this whole array of things. And what we'll do then is we'll basically start counting down our wave delays array here. So we'll say wave delays, which is the name of our array up here. And what we want to do is count it down at whatever position we're currently at. And the way we're tracking that position is using our wave tracker. So we'll say wave delays, I spelled that wrong as dealies, but wave delays, and then we put inside a square bracket, we'll type wave tracker. So to start off with, our wave tracker will be 0. So it'll look in the wave delays array and it'll look at position 0 in the array, and it'll go over here and find, okay, that's 5. So if that's 5, we can start counting that down. So we'll say minus equals time dot delta time. So we're counting down our value in the array. And then the next thing we do is check, okay, we've been counting that down. Let's find out if the position we're at in our wave delay, so our wave delays bracket wave tracker, is that now less than 0? Because if it is, what we should do is spawn the next object in the array. So in our case, that'll be at position 0 in our waves array. We'll go, okay, bring in that first wave. We'll say instantiate our wave. So we go into our waves array and we go to it at position 0, and we know that that's tracked by our wave tracker. So that'll be waves position 0, load that object in. Where do we want to put it? We want to put it at our wave spawn point. So wave spawn point dot position and wave spawn point dot rotation, like that. Okay, so we've got our object being popped into the world now. So while that's popped in, we need to move on to the next element in the array and say wave delays, or sorry, wave tracker plus equals 1. So that's how we add 1 onto our wave tracker. Now, what we could also use is another bit of kind of short code within Unity, is rather than saying wave tracker plus equals 1, we can just say wave tracker plus plus. And what that does is it's a short way of writing just add 1 to the number. So it'll just add on 1 and our wave tracker will move up to the next bit. And so then in that case, what will happen is, so we'll get to the end of this array here. We'll go back up here and it'll start counting down the next value. So it'll go to element 1 and it'll go, okay, start counting down the value 3, and it'll count that down as it goes, and it'll go, and then once it gets below 0, it'll load up our object at position 1. So it'll load wave 2, and then it'll add 1 on and it'll go to wave 3, and that'll be absolutely fine. It'll start counting down again, it'll get to 0, it'll load up the wave 3 object that we have here, and then it'll update wave tracker again. But now we're going to cause a bit of an error. We're going to have a situation where our wave delays now will be looking to count down a value at position 3 in our wave delay, but there is no element 3. There's only element 2. So that's no good. So what we want to do instead is say we've added on our wave tracker here. We're going to make sure and check that our wave tracker isn't gone any further than what our waves delays should be. So we'll say here, if our wave tracker, that should be a bracket back here. If our wave tracker is greater than our wave delays array dot length. So our dot length will basically give us how long I don't know why that's gone red. If our wave tracker is greater than or equal to, actually, is what we should use. I don't know why that fixed it. That shouldn't have been an error. I think it was just being a holdover, an error. But what we actually want to do is check that this is greater than or equal to. Because what our wave delays dot length will tell us is the size of the array. So at the moment, our size is 3. And what we're saying is, okay, if our wave tracker gets to be 3, then that's too far. So if it goes looking for element 3 here, we're going to get an error. So what we're going to do instead is say, okay, check and see if our wave tracker is equal to our wave delays length, which is 3. And just in case it somehow gets any higher than that, we want to say also check if it's greater than or equal to our wave delays dot length. So then if it is equal to that, then we can say, okay, we don't want to be spawning any more waves. Instead, what we're going to do is set our spawning waves to be equal to false. So it'll stop trying to loop through this whole system and it won't give us any errors in our game. So let's save this and see this all in action now. We'll go back into our game, let it compile down the bottom. Once it's finished compiling, there we go. Everything should be hooked up the way we want it to be. We want to make sure that we are actually spawning waves as soon as we start the game. And now we can press play. And we should get our waves of our enemies starting to come into the game. So you see it counting down. And there we go. There's the first group of enemies coming in. Okay, I got destroyed. That's okay. That doesn't matter too much. But we see our second wave comes in. And then finally our third wave now should come in. I don't know why it didn't. Oh, they don't have any movement speed. That's why. That's what happens when you just quickly set up a wave. But you can see they did actually spawn in. And you can see as well that we stopped spawning waves then. And we didn't get any errors. So we know that our wave system is now working perfectly and working the exact way that we want it to.